In this one, we have a test statistic in a left-tailed hypothesis test. And this says it's z equals negative 1.92. That tells you that we're using the z-scores table. And we have a significance level of 0.01, and we're just trying to find the initial conclusion for the hypothesis test. So given this information, since we have the test statistic and we know it's a left-tailed test, we can actually just look up this value in our z-scores table. So if we look up negative 1.92, we're going to get a p-value of 0.0274. And our alpha was 0.01. So in this case, the p-value is greater than the alpha, and that means that our conclusion would be to fail to reject the null hypothesis. Okay, next question. We've got 301 scores from last year's ACT tests. The sample mean of the test scores was 19.85, and the sample standard deviation was 4.80, and we're constructing a 90% confidence interval for the mean test score. Okay, so here's what our formula looks like. We need to use the t-table. Our degrees of freedom would be 300, and the alpha is going to be 0.10. If we go down to our t-table down here, we've got 300, and remember we're looking under area in two tails. So here's the 0.10 is the second column from the right. That gives us a critical value of 1.65. So that means we can go back and put in 1.65 for the t. Our sample standard deviation was 4.8, and n was 301, and that gives us a margin of error of 0.4565. Now our point estimate is the sample mean test score, which was the 19.85. So now we want to take 19.85 minus our margin of error. We're just going to round that margin of error to 2 decimal places now, so 0.46, which gives us 19.39. And if we add the margin of error, we get 20.31. Now if you notice in our choices we don't have exactly these values, which may be the difference of using the t-distribution table. Probably when I gave this problem on a test before, I was having them use calculator values. So let's pick the closest ones here, which would be this one. And I'll go back in and correct the answers for this after I get done with the video. Okay, now we have the top 5 Crayola colors and the probabilities for each one. So we have our distribution, and we would test sample data for goodness of fit to the distribution that we have. So the question is, if the sample size is 800, what would be the expected frequency for the blue category? All we're doing for expected frequencies is taking our sample size of 800 times the given proportion for that category. So we would be taking 800 times 0.30, and that would give us 240. So there's our correct answer. Okay, number 19 is just a question about how many degrees of freedom, and this is in a test for independence. So remember, if you're doing a test of independence, then the degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So in this one, since we have 3 rows, then we'd have 3 minus 1 and 5 columns, so we'd have 5 minus 1. So that's 2 times 4, which would give us 8. So our degrees of freedom here would just be 8. Number 20, we have a survey of 2,225 community college students. 1,157 of them were under the age of 23. And here we're just trying to find a point estimate for the population proportion. Remember, a point estimate is just a sample statistic. So in this case, all we want to do is find the proportion that we get for the number that were under 23. So we're going to divide the 1157 by the 2,225, and we're going to put that in decimal form. That actually comes out to be 0.52. Okay, next question. This one we had a random sample of 139 drivers, and they were looking at the number of vehicle accidents and the number of speeding tickets for each driver. So the sample mean for the number of accidents was 1.3. Sample mean for the number of tickets was 6.5. We did a linear regression analysis and came up with a correlation coefficient of r equals 0.597. We've got a linear regression equation and a p-value. And what we want to do is find the best predicted value of the number of tickets for a driver with 3 accidents. So the big question here is whether there's enough evidence of a linear correlation to be able to use that linear regression equation or not. And really all we have to do in this one is look at the p-value, since we already have that. Since our p-value is 0.0028, that's less than our significance level of 0.05, that means that there is sufficient evidence of a linear correlation. So we can use this linear regression equation. Now, if the p-value were larger than 0.05, for example, if the p-value were 0.06, then we wouldn't be able to use this equation, and we would go back to our mean for the number of tickets, our sample mean, which was 6.5, instead of trying to use the linear regression equation. But since there is enough evidence of a linear correlation, then what we can do is put our number of our number of accidents, which is the x, into the equation in place of x, and then just calculate what our y would be. So that would give us number of tickets of 12.4. Okay, number 22, we have a p-value for hypothesis test, which is 0.0252. The significance level is 0.01, and we're just trying to find the initial conclusion for the test. So again, all we're doing is comparing the p-value and the significance level. Since the p-value is greater than our significance level, then our conclusion is that we fail to reject the null hypothesis. Okay, in this one we have 3 graphs, and we're trying to match the graphs to the correct linear correlation coefficient. So you need to pay attention to whether the pattern in general goes up or down as you go from left to right. If it goes down, then your correlation coefficient will be negative. If it goes up, then it will be positive. So right away, looking at these 3 graphs, the only one that goes down is number 2. So we could automatically match that to the only negative correlation coefficient that we have here. So that one would have to go with graph number 2. Now for the other 2, notice that graph number 1 has looks a little bit more like a straight line pattern than graph number 3. In graph number 3, the points are more spread out, less of an obvious linear pattern there. What that means is that for graph number 1, the correlation coefficient is going to be closer to 1. So that would mean that it would be the r equals 0.915, and the one with less of a linear pattern would be the 0.622. So this would be graph number 3. Okay, the minimum sample size that we need to construct a 95% confidence interval, if we want a margin of error of 5 percentage points and a planning value, which means a value that we already can guess for p of 0.30. Okay, so here's the formula that we're going to use for this one. Since we do have an estimate for p, or p hat, the z is going to be our critical value, so we need to find a critical value for an alpha of 0.01. So we're dividing the alpha by 2, then we're going to look up that value in our z-scores table. So 0.005. Again, this is exactly halfway between 2 values, so we would use 2.575. So we're going to put 2.575 in there. And for our p and our q, we're going to use the estimates that we've got. For p, we're going to use 0.30. And for q, it's going to be 1 minus p, so that would be 0.70. And the margin of error, remember everything in this problem that's a proportion has to be in decimal form. So when it says the margin of error needs to be 5 percentage points, we're going to write that as 0.05. And that is especially important in this problem in order to get the correct answer, that you do put everything in decimal form. So if we plug all that into our calculator, we get 556.97. We're always going to round up to the next highest whole number when we're doing sample sizes. And in this one, depending on whether you used your calculator or the table to get the critical value, you could get just a little bit of rounding error. So the one that's the closest to the value we came up with is the 0.558. Okay, now we're selecting the correct null and alternative hypotheses. We've got a poll that showed that only 28% of adult citizens support a bill. A group of representatives claims that this is incorrect because their own poll shows the percentage of citizens supporting the bill is different than 28%. Again, the keyword here is different. That means that you're going to have a not equal to for your alternative hypothesis. So the only one of these choices that has a not equal to for the alternative hypothesis is the second one. And notice that the null hypothesis again is exactly the same. It has the same number, only it's an equal instead of a not equal. Okay, so that's all of the questions on this sample final. It's actually going to be very similar to your actual final. There will be the tables at the bottom of the final, just like there are in the sample. And of course the questions will be slightly different, but it's going to cover basically the same material. If you can do the questions on this sample final, then you should be just fine for the actual final exam.